Hey students, we are going to look at scatter plots and using those scatter plots to determine a line of best fit. But first, I'm going to give you an extra credit opportunity. If anyone will take a picture of these problems, write them down or print them off and send me the answers, then I will give you a bonus point per correct answer on your 6.02 what is it called? Line of Best Fit quiz. And that was from March 11th. So you have a small opportunity for extra credit, and then you'll have another one this Friday. All right. So you can take advantage of those if you choose. All right. So when we're looking at scatter plots, we're going to find a couple of things can happen. They can either show there's a positive correlation between two sets of data. So, when you create a scatter plot, you use two different sets of data. So for example, you would say one of them would be age and one of them would be shoe size. So as you'll find that as a person's age increases till about 18, their shoe size is probably going to increase as they get older up into a certain age. So if both sets of data increase, that means those two sets of data have a positive correlation or positive association or positive trend. All those words can be used. Now, if you have a negative slope or a negative correlation or a negative trend, that means that one set of numbers have to increase because the x-axis is always going to be increasing. The other set of numbers would be decreasing. For example, as the number of hours spent watching television increases, then there's probably a correlation that the amount of time spent reading a book would decrease. So that as the number of hours increases that you watch television, probably, or maybe the number of hours reading books would decrease. So if that's true, if those two things have a correlation, that would be an example of one. All right, now sometimes you'll have two sets of data that have nothing to do with each other. And so you'll see a scatter plot that looks like this. There's dots everywhere. For example, if I said, what is your street address and how many books did you read last week? Well, probably those two things have nothing to do with each other. We can still gather data and we can still put that data on a scatter plot, but we'll probably find out that your street number of your address has nothing to do with how many books you read, right? All right, so if we could draw a straight line between most of the dots of our scatter plot, we would say that that has a linear correlation, because if I drew a line straight through there, that would be a straight line, either positive or negative. The one on the right shows a negative correlation. Now, if I had to draw a line through this trend, it would be non-linear. So my line would be going down like, I didn't have my pen ready. So obviously this is going to be a non-linear negative correlation, right? This is going to be a linear correlation positive. This is a linear correlation negative, and this is going to be non-linear because of the shape of the dots. And then once again, we could have a one that would be neither linear nor non-linear because there's no association between the two sets of data. Now you can have a very strong positive correlation or negative correlation, and then you might have one that's moderate. So even though those dots do generally tend to go up to make a positive correlation, the dots aren't as close together as the top example. And then a weak correlation, I would say that one has no correlation. I wouldn't even call that weak. I would say that this one has no association between the two sets of data. So that's not a very good example. I should have changed that. All right, so let's look at these. What do you guys think? Let's look at number one. We're going to fill in the words increase or decrease. So the more one studies, As the number of hours you study goes up or increases, your grade will probably increase, right? So you would say there is a positive correlation between those things. The more a person diets, as the time spent dieting increases, their weight will probably decrease, right? So that is a negative correlation. The longer one diets, as the time one spends dieting increases, the amount of weight loss will increase. The amount of weight loss will increase. That would be a positive correlation. The more a person exercises, their muscle mass will increase. So that is a positive correlation. The more a person exercises, as the minutes that a person exercises increases, their fat mass will decrease. So that's a negative correlation. The more a person jumps rope, their heart rate will increase. So positive correlation. The more a class talks, the teacher's patience will decrease, negative correlation. And the more a person reads, their vocabulary will increase. So that's a positive correlation. So notice the first, whatever's mentioned first has to increase always. And then depending on what the behavior of the second part of the data is, that's where we get the correlation. All right, so from birth to your current age, what happened to your height as you grew older? So your height increased. So you had a positive correlation between your height and your age as you've grown. When dieting, does a person expect their weight to go up or down? So as the amount of time spent decrease. So we've already kind of talked about these, right? So the third one would be increase, positive correlation. And the fourth one would be decrease, negative correlation. All right, so when you guys create a scatter plot, I almost said box and whisker plot, you're going to figure out what you need to label your two axes by. Now this one tells us, they're saying that we're going to use 1 through 6 as our x-axis, and we have to go at least up to 8 for our y-axis. So 1, 2, 3, 4, 5, 6. So it would help you the most if you guys sketch this with me and made one yourself. And then we want to make sure we go through at least 8 on our y-axis. And we have just enough space. So when this represents 1 point, right? So you're going to go x is 1, y is 2. And there's your first point. When x is 1, y is 3. My pen's going to make those crazy lines. When x is 2, when x is 2, y is 4. When x is 3, y is 4. When x is 3, y is 5. When x is 4, y is 5. When x is 5, y is 5. When x is 5, y is 7. And when x is 6, y is 8. All right, so my pen doesn't like little dots. I don't know why, but anyway. So would you say that these two sets of data have a positive correlation, a negative correlation, or no correlation? Well, it definitely looks like there's a positive correlation going on, right? And when you draw your line of best fit, you want to make it straight and you want to try to go through the center of the dots. There should be about the same amount below the line and above the line, okay? So you don't have to necessarily hit any of the dots really, but you want to try to go through the center of them. So I would say that this is probably a little low because there's more dots above the line. So if I had to do again, I'd use a ruler and I would make that line just a little bit higher because you want about the same amount above and below the line, but it definitely has a positive correlation. All right, so we're gonna do hours as our x-axis and miles as our y-axis. So we have to go through at least 8 on our x-axis. So 1, 2, 3, 4, 5, 6, 7, 8. Now, when you think about your y-axis, our biggest number is 35. So we want to get through at least 35, 5, 10, 15, 20, 25, 30, 35, 40. Oh, well, that's perfect. I'm going to count by fives. You want to use as much as your graph as possible, okay? You want to try to use almost all of it. And then you always, of course, need to label your two axes. What are these numbers down here? They're hours. What are these numbers over here? They're miles. And then just put the dots one at a time. Don't try to go in any kind of order. So the first hour, we went 35 miles. The second hour, we went 29. The third hour, about 29. The third hour, we went about 26. The fourth hour, we went 20. The fifth hour, we went 16. The sixth hour, we went 9. The seventh hour, we went 6. And the eighth hour, we went 0. Now, I'm going to show you a real quick way how to put all these points into your calculator and get your line of best fit. Now, this is a very strong negative correlation. So we could probably guess the line of best fit pretty closely. But I am going to show you how to use your calculator if you have the kind of calculator that I have. So the first thing we're going to do is start with our y-intercept, and we're going to know that part of my equation is going to include my y-intercept. In this case, it's going to be a 40. And then you want to pick 2 points, any 2 points from this graph, and you're going to use the y2 minus y1 over x2 minus x1. So y2 is 29 minus the first y value is 35, and then we're going to do 2 minus 1. So we're going to say 29 minus 35 over 1 is -6. So I'm going to guess that our line of best fits equation is -6x plus 40. Now I can be exactly sure if I use my calculator, and we did this last week in a Zoom. You're going to hit the data button. You're going to hit the data button, and it brings up 3 columns, and you're going to type in all of those x values, every one of them. 1, enter 2, enter 3, enter 4, enter 5, 6, 7, and 8. And then you're going to go to the y column, and you're going to do 35, 29, 26, 20, 16, 9, 6, and 0. And then you hit the green, or the whatever color that is, the second button. Hit the data button again. Arrow down and say 2 variables. And then you hit enter 4 times. 1, 2, 3, 4. And then you scroll down, way down. You're scrolling way down, and you're looking for d little a. And on my calculator, it tells me that d little a is -4. That's my slope. And you're looking for e little b, and that's my y-intercept. And if I round it to the ones place, I get 40. So look how close we are, because this is such a strong negative correlation. According to my calculator, using all of those points on the graph, our equation is -4x plus 40. So that's pretty close, and we eyeballed it. So that we did pretty well. But if you use all the points on your scatter plot, you can't be exact. However, some problems with scatter plots is that you don't have the data like right here, and you'd have to kind of guess these numbers from just dots being plotted on a graph. And also there can be so many dots that it would take you all day to do that. Okay, so it just depends on your data. All right, so I want you guys to make number 3, and I want you to Canvas inbox me and tell me what kind of correlation is there between wind speed and temperature. As the wind speed increases, what happens to the temperature? I want you to show me, I want you to make this scatter plot and send me the answer, okay? And same thing with bird populations. I want your years to go on the bottom. So these will be years since 1992 on the bottom. So the first year, so we're going to let this be 0 because how many years since 1992? 0. And in 93, wouldn't there be 1 year since 1992, and then 2, and then 3, and then 4, and then 5, and then 6? 1, 2, 3, 4, 5, 6, 7, 8. All right, and then your numbers are spread out between 22 and 51. So I hate to even start with 0, really, but 5, 10, 15, 20, 25, 30, 35, 40. Ugh. I hate to start with 0. Let's do one of these little things on our graph, and this means that we're not starting with 0. That little break, that little fancy thing that my pen won't let me draw. Oh my gosh, it's supposed to look like this kind of. It still won't let me draw it. I'm drawing a really big one like that. It looks like a heart monitor, but sideways. And that means we're not starting with 0. We are changing our numbering. So I want to do 20, 22, 24, 26. Oh, we can't do that either. How about we number by 4s? How about we number by 4s? What do you think? Will 4s work? So we do 24, 28, 32, 36, 40, 44, 48, 52. Okay, that works. So use that numbering. So this is 0 years. So years since 1992, and this would be active clusters of bird populations. All right, so graph that and tell me what kind of correlation you see. All right, guys? All right, now sometimes you have all of this data that's pretty close together, and then you have a number that's far away from the other sets of numbers, the other set of numbers. So that would be your outlier right here. So when you do your line of best fit, you want to be aware of your outlier, but you don't want it to influence your entire line of best fit. So we're not going to draw our line out here and try to get it between L and all of these, right? That wouldn't make any sense. So we are going to, think about that outlier, because of course there can always be outliers, but generally there is a very tight negative correlation between these two sets of data, except for that outlier that's out there, okay? All right, so, and you've had that vocabulary term before. So it's easy on a scatter plot to spot an outlier. It's going to be far away from the rest of the data, literally. All right, so here we have a table, and they want us to figure out what kind of correlation is going on. Now, this was pretty easy because it looks like generally the numbers are in numerical order, at least they are on the x-axis. So we could probably guess, but if you have a question like this, and you will, then you're just going to sketch a simple little scatter plot, okay? So 2, 4, 6, 8, 10, 12 on my x-axis, and my y-axis has to go up to 9. Man, I can't draw a straight line. 1, 2, 3, 4, 5, 6, 7, 8, 9. And just to be sure, you're just going to sketch a really quick scatter plot. Why can't I speak? So we're going to go 5 and 4, about right here. 6 and 2, 7 and 10. Oh, I've missed 10. We should have a 10 up here, shouldn't we? It's about 10. And then, wait, hold on. What did I do? Oh, 7 and 10. And then 8 and 7, 9. Oh my gosh. This pen is driving me crazy, you guys. Did I do 8 and 7? It wouldn't let me draw my little dot. So 8 and 7, 9 and 1, 9 and 1 down here, 10 and 2, and then 11 and 8, 12 and 9, about right there, and then 13 and 5, way over here somewhere. So do you think there is a correlation between the number of customer service representatives and customer service ratings? I don't see a trend. There's dots kind of everywhere, right? Some of them are down here at the bottom, some of them are way up here at the top, kind of in, you know, I would say there's no correlation between the number of customer service representatives and the customer service rating. And you only know that you can make an assumption by just looking at the numbers, but you really won't know until you sketch it out. Okay, so be careful when you have a question like that. All right, here's a good question. We have the average rent per month and years after 2000. We're going to draw a line of best fit for the scatter plot, and then we're going to write an equation for the line of best fit. So be careful when you draw your line. Let's try to draw it as good as we can. My pen is not working. All right. Oh, it's a little high, little high. I should be a little, let me try one more time. Now it's easier. Now, obviously you guys are looking at a computer screen, but if there's any way for you to actually draw it, it's easier for you to write the line of best fit. So I'm going to use the line that I just drew in order to write the equation. Now, obviously the easiest thing to do is to find the y-intercept. So we're going to use a y-intercept of 800. And even though we may not be exactly right, we know we're very close, right? It looks like it's actually a tiny bit less than 800, depending on where your line of best fit is. And then let's try to use a dot that's right on, you see what this looks like? It's right on the coordinate of 6, 1000. So we're going to use the points 0, 800, the y-intercept, and we're going to use this point right here, which is 6, 1000. And we're going to use our slope formula, y2 minus y1, and then x2 minus x1. So we're going to say, what is 1000 minus 800? And that number is 200. And then 6 minus 0 is 6. So if I divide 200 by 6, I get about 33. So about 33. So that means each year after the year 2000, the rent increases by about $33 per month. And the lowest apartment rent we found was 800. So in the year 2000, the average apartment rent was 800, and then it increases about $33 a year. Okay, according to what we just found. Cool. So let's check a point. Let's check 12 years after 2000. So according to our equation, the rent should be around, let's do 33 times 12. And then we're going to add our y-intercept of 800. So I get about $1,100, about $1,200. And this is just above $1,200. So that point's a little bit below our line, but it's not very far off, right? It's pretty close to what we see on our trend. So you're going to have some questions like this, which is the line of best fit for the scatter plot. So all the points are in the same position. You want to try to find the line. So C, obviously the points are going down, but our line's going up. So C is completely out the window. Now B, it looks like they're trying to connect one of the dots to one of the dots, but it doesn't really go through the middle of most of the points, correct? So A is going to be our best answer. So you want to look for a line that has about the same number of points above and below the line. So A is going to be the best answer on that one. Oh, is that it? I thought we had more. Okay. Well, so there's just some examples for finding the line of best fit and the correlation. So you're going to have questions on all of that. All right. So as you go through the work this week, oh my gosh, you guys, I am struggling with words today. If you need my help or have any questions, please let me know. Everybody have a great day.